Okay, determine whether each function is an example of exponential growth or decay, then find the y-intercept. So again, first off, great growth or decay. 100 is your initial value. 0.25 is less than 1. When I multiply by a number less than 1, that's a decay, because it would just keep decaying, because I would repeatedly multiply by 0.25. So that's decay. Now your y-intercept, okay, we always set x to the 0 to try to find the y. The opposite letter always goes to 0. Now you can use your head here. Anything at 0 power is 1, but it's 1 times 100, so it's going to be 100. Okay, so this is my initial number. That's not the one I go with. 18 is bigger than 1. That's growth. If I take a number times 18 and keep timesing it by 18, we grow. Now the y-intercept, now if I would put a 0 in there, that makes 1 right here. 1 times 7/8 is 7/8. Growth with a y-intercept's like your initial point. Now, some of you not good with just because you have a fraction doesn't mean it's a decay. Take your calculator real quick and divide 5 by 3. Dude, that's bigger than 1. That's an improper fraction. It's bigger. Improper fractions are always bigger than 1 when the top's bigger than the bottom, okay? That's growth, because that's bigger than 1. Here, I'll just put greater than 1, then it's growth. That's a greater than symbol 1. 0, anything at 0 power is 1, and then times 0.2, 0.2. Okay, here's my power right here. 1/5. Now is 1 out of 5 bigger than 1? No, it's not. Okay, so less than 1 means decay. Now anything to the 0 is 1, but would multiply the 1 times 0.7. So the y-intercept is 0.7. So those are 2 answers we need to have on all those. Okay, now graphing exponential functions. Just do the graph right here. Now, here's my independent variable. It's in an exponent with a base 3. Okay, so I know that the way to set this up is picking integers, just a fair amount of integers, 2 through -2. There's also that issue of the asymptote, where y always starts at 0. Now, it might not stay there. Now, just raise 3 to the second. Don't worry about the plus 3. 3 to the second's 9, so we'd have 1/9, not -9. 3 to the first is 3, 1/3, and 3 to the 0 is 1. Now, with the x, you have a plus 3, so you have to do the opposite of plus 3, which is minus 3. Because see, if I take 2 minus 3, that's -1. -1 plus 3 takes me back to 2, okay? Now, the outside operations, we don't invert those. We do the same way, so times 3 minus 6 in that order. And also that's done to the asymptote too, because the asymptote is a y. So 2 minus 3 is -1. 1 minus 3 is -2. 0, -3, -4, and -5. Now I'm going to take all these times 3 and subtract 6. 9 times 3 is 27, minus 6 is 21. 3 times 3 is 9, minus 6 is 3. Okay? That was just dumb luck that stayed a 3. Okay? 1 times 3 is 3, minus 6 is -3. 1/3 times 3 is 1, minus 6 is -5. 1/9 times 3 is 1/3. Use your calculator. Minus 6 is going to be -5 2/3. If I take 0 times 3, that's 0, but then when I take the 6 away, that's -6. Okay, you ready to graph it? Graph this one first. You'd have to go by 5s probably. So -1, 5, 10, 15, 20, 21. And then your -6. Now don't go 1, 2, 3, 4, 5, 6. You go 5 and then 6 would be right there. -6. -2, 3. Now again, don't lose sight of track that you're going by fives, okay? -3, and that's good enough. I just need those first three, and I can see my graph. Okay, domain and range time, x and y. Now, since the arrows go on both sides of that, x would be all, because I could keep putting in numbers for x. But that y, there comes a point where you can't move past it, and that's the -6. So every point's above that, so it's going to be greater than, but not equal to. Okay, that's that graph. Now there's going to be another graph, which I think I'm going to let you use on the test, okay? Graph the function, identify the domain and range. Well, I will write the one you can use, okay? First off, you got to invert x and y, because you're gonna make an inverse function. And also, I forgot again, okay? Put a parentheses just with the x, please. Okay. Okay, so parentheses y. The -2 is not in the parentheses. Okay, that's important where that parentheses begins and ends. I forget. Okay, because otherwise you don't know if the -2 is included with the x in the logarithm or if it's outside the logarithm. Now, I need to isolate my logarithm. Remember how I accomplished that? That -2 can't be there. So +2, and we have x plus 2. Now get this out of a logarithm to an exponent. The way to do that, whatever's in parentheses is by itself, base 3 to the power of x plus 2. Okay, now I think everything's pretty much good to graph because the y is by itself. Or not graph, make a table for it, I should say. So again, same as the last one. Okay, 3 to the second, and there's that deal of the asymptote, y equals 0. So 3 to the second's 9, that'd be 1/9. 3 to the first is 3, 1/3. 3 to the 0 is 1. Okay. Now, you're going to -2 from your x, but the y's we don't have to do anything to. There's nothing outside, nothing going on outside. Okay, so 2 minus 2 is 0. -1, -2, -3, -4. And the asymptote ain't going to change either, okay? Because if don't have any outside operations with y, I wouldn't change the y's or the asymptote. Now the problem is the fundamental deal that we had to flip the y and the x, so we need to put the inverse of this equation. 9, 0 instead of 0, 9, 3, -1, and 1, -2. Now the asymptote's not a y, the asymptote's now an x. So the asymptote is now this, up and down, as opposed to the last one where it's horizontal. So 9, 0. 3, -1. I just do the first three. I'm not going to graph all those fractions. You don't need to. Okay, that's silly. 1, -2. So you see what's happening. It's just inverted. Now, all is now your range, and now your domain, you use x with the 0, and all points are now to the right. Okay, so greater than. So pay attention to those graphs, okay? This next thing is just a little part you got to memorize. Write each expression in logarithm form. So you need log. Whatever's the power is what the log's equal to, and that's all by itself. Whatever the power's base is goes down here, and then 81. Okay, my next one. -2, 8, this is the same as this, 1 over 64, okay? This battery's not going to last, so I'm going to have to make this into 2 videos, sorry. Okay, evaluate each logarithm. Logarithms are easy to evaluate. There's 2 ways to do it. First, multiply 7s to try to reach 343. 49, there's 343 there. Use your calculator, so it's 3. Easy. Okay. Remember, there's two directions. If that doesn't work, then you use your change of base. That means the log over the log. If you don't like the change of base terminology, it's log over log. Okay, so 1, 2, 3. Okay, and that equals 512, so it's 3. Okay, I set my product at 651, so 9 to the what is 651? Well, 81, 729, that's 6,651, so that's 4. Now remember, you can just do 16, you can just use 16 if you put a negative sign, okay? Because it's the inverse of 16, it's inverted, okay? It's 1 over 16. So 1, 2, 3, 4, and there we have it. That equals 16. But it's negative 4 because it's 2 to the negative 4th is 1 over 16. Okay, write an expression as a single logarithm. Okay, so what's your base of the logs? They have to be the same base, base 2. Then you make a little one parentheses, 1 and only, and everything's going to be inside of here. So we have x and b. It's minus, so it's x divided by b. X is to the power of 6, b is to the power of 3, and that's all she wrote. Now you're going the other direction here. You need to expand this into multiple logarithms. First off, count how many factors you have. That tells you how many logarithms. You need 3. So 8, x to the third, but then either cross out or erase the third and it goes to the front. Okay? Same thing with the y to the fourth. Now multiplication means adding. Okay. And there we have it. Okay. I'm actually gonna, this is a good place to stop it, and then I'm gonna make another one because I gotta charge my battery on this.